Hello, this is Mark Vondrasek, and this is episode 2 of The Quantum Revolution of Education. And for this one, I just wanted to give a brief synopsis of what I call the quantum mechanical student. Okay. Where I left off in the first episode is the fact that in order to act differently in the classroom, we have to have a new mindset. We have to think differently in order to act differently. And so the mindset I'm proposing, um, I want to give the inspiration behind this and where it comes from. And it comes from my previous life as a particle physicist prior to before I started teaching. And so what happened was in quantum mechanics, a revolution that happened in 1900, about 120 years ago in physics, is when we went from Newtonian science into quantum science. And we started discovering particles and thinking about atoms and things like that around that time. And it was discovered that something like an electron, one of the particles that we're all made from, can, and we normally think of as a particle, okay, little particle whirling around the nucleus of an atom is what we're usually taught in school, can sometimes actually have a second personality. It can act like a wave. And so we call that particle wave duality. And the reality of it is when you're not watching an electron, you don't know if it's a particle or a wave at any given moment of time. And so that the best we can do is kind of give it odds. What's the probability, or what are the odds that it's an electron is acting like a particle right now, or is it acting like the wave? And what's weird in quantum mechanics and the actual mathematics of quantum mechanics is the fact that we literally have to treat the electron as being both a particle and a wave simultaneously when we're not observing it. And a second feature of this is the fact that how you look at the electron, how you observe it, what experiments you do, will determine which personality you see. So we have influence on that. Now, what I mean by that is if we were to take an electron, this picture on the left is something I took in my lab, and it's from a cathode ray tube, an electron beam. And what we did is we sent the electron beam through a little hole, and it produced this bullseye, kind of like a bullseye target type pattern. Well, that is what we call an interference pattern in science, and only waves can do this. So if we look at electrons in that kind of experiment, when it goes through little slits or holes, it'll act like a wave. Now, the picture on the right was taken in an old detector at Fermilab. It's something called a bubble chamber, where these tracks that you see are particles like electrons that are moving through material, and they leave tracks behind. And that's something more like a particle would do. So in those types of experiments, you see the particle personality come out. If we let those same electrons flying through the material go through a little hole, you go back and you see the wave personality of that electron. And so this particle wave duality and the fact that how we look at it influences which personality is selected. Okay, that's the kind of idea that we're going to be using to build this argument of how we can look at students, how we can think of human beings in kind of like this quantum way. Okay, it's going to sound weird at first, but if you watch the future episodes, we're going to kind of build this up and see what I mean by this. Now, by the way, in the mathematics of the physics behind all of this, we use something called a wave function that talks about the odds or the probabilities of finding particles in either a wave or a particle personality state. I'm going to argue in an episode or two that I think of human beings as having wave functions, what I'll call a personality wave function or an intelligence wave function. And it's this mix of states, which is really the important part. And that when we're not observing the particle, or a human being for that matter, we don't know what they're doing. We don't know what personality they happen to be in at any given moment until we actually observe them. So this is where we're headed with all of this. And hopefully I'll make a strong enough argument where it'll have some merit, and we'll see where it takes us. So thank you. Look forward to episode 3.